Hello and regards to everyone watching this presentation. This is Naveen and I'm presenting my project report on autonomous vehicle system. So without getting any further ado, let's get started. So these are some of the topics we are going to cover in this presentation. We are starting at introduction and then we'll guide you through to advantages and future scope of this project. So we will start at the introduction. An autonomous vehicle is often in layman terms called as a self-driving car, which is not the same term because a self-driving car is only capable of taking decisions under the guidance of a human supervisor, instead of an autonomous car which can take decisions on its own. So an autonomous system takes its senses from the environment and then use its actuators to perform some action. Similarly, in cars, the autonomous system performs sensing of the environment through some of the sensors like radars or cameras, and then use its actuator, which is in this case accelerator or brakes or steering command. So this is how an autonomous vehicle system works. Moving ahead, we have two different terms, autonomous versus automated. We earlier discussed about self-driving car. We can call it as automated driving system, but an autonomous driving system can work on its own. It has a thinking of its own. Let's say we say that we ask a car which is autonomous to take us to our office, but it instead take us to a beach. So that will be an autonomous system because the car developed a thinking of its own, and it did whatever it wanted to do instead of what it has been told to do. Uh, in an automated system, though, it will always follow a command. Moving ahead, we have different levels of automation according to SAE, which starts at level 0 and goes to level 5. At level 0, we have no the car has autonomous system has no control over the car, and the human is responsible for almost everything. The car system can give warnings, or you can say jump into the driving system every once in a while, but most of the work is done by human drivers. Moving through these levels, level 5 means there is very little to no human intervention, and the car fully drives on its own. Moving ahead, we are looking at requirements of an autonomous vehicle system. Then the basic requirements is automating the commute of daily basis. We have to go to our offices, we have to go to different places to get to our work, and that way, if we have a car that can drive on its own, we will have more time to work on things that matter for us. Uh, mm, Adding to it, the safety on roads is more of a concern in every country, and according to some statistics, global statistics, there are more deaths in car accidents, in road accidents, than any other causes. So next up, we have the approach used in this particular project that we used to develop this autonomous system. We used end-to-end learning approach in this process, which is different from other learning approaches like lane finding, in which we do not give the system how to figure out what to do. In other systems like lane detection, the system is feeded with an if-else condition set, like if then else rules, which helps it figure out what to do if there is an obstacle in the path. Instead of doing that, we have an end-to-end learning approach which can help us not feeding the custom or human-centric features. Instead, the car or the system can learn what matters on its own. So what we do is we use convolutional neural networks, which takes in images from the cameras captured by the cameras on the head of the car, and it processes it to generate some steering command, or how much to accelerate, or whether to put a brake. So uh, given these images, it generates an estimation of what car command should it give, and then do, also have the steering commands given by a human driver while driving the car, and we give this as a feedback to the neural network, and it back propagates to learn new values of weights and biases. Moving ahead. Next, we use this model to train over 10,000 images from the trial run, which was driven by a human. And these data set are present in format of three images, triplets of images from left, right, and center cameras of car. And then we also have the steering command given by a human driver that we use to as a feed for the CNN to learn. Next up, we have the working of CNN, and why we haven't used a fully connected network instead of convolutional neural network. First of all, because it's for 1440 by 720 simulator, we have a 1440 by 720 pixels image, and it's a three channel image. So there are three colors: red, green, and blue. So we have to model 1440 by 720 by 3 neurons in the first layer, and if we have like a thousand neurons in next subsequent layers, even lesser, we can still reach billions of weights and biases. So that way it's practically infeasible for a fully connected neural network to learn weights and biases for an image set of 10,000 images. Moving ahead, a convolutional neural network is basically based on the convolution operation, which is more of an edge detection technique. So instead of using the pixels as its features or its first layer of neurons, we can use the edges or the edge matrix of the convolution operation as the input to the neural network. So it performs so much better than the fully connected network in the scenarios of images, and we save a lot on compute power. So next up we have the architecture of the convolutional neural network that is used in this particular case. It is a 9-layer neural network, of which first 4 layers are fully connected neural network, and then we have a couple of con 2D layers or convolutional neural network layers. Moving ahead, we are discussing the architecture of data collection system. We have 3 camera setups and a steering command that is operated by a human driver. So these data are stored in SSD or blob storage in case of cloud, and this is processed in a processing unit like a graphical processing unit like TPUs or NVIDIA drive. Next we have is the training process of the neural network. We feed in 3 images to a pre-processing script, which what it does is it performs some random shift and rotation operations onto the images. This is done because we don't want our network to memorize the images and memorize the turns and memorize what angle it is, what steering command is given for that particular image. So we manipulate the image a little bit, and then we feed it into the convolutional neural network layer, and then it estimates what steering command it should give, and then we compare it with the human steering command, and uh, after this comparison, the neural network gives itself a feedback and back propagates to generate new weights and biases for the layers in the neural network. Next, we have some screenshots of a project of a simulator that we used to test and train this model. This is the main menu of the screen. We have two maps here. One is used to generate the training examples. We used it in forward and backward motions to generalize the data and reverse the terms. And we use the second map, which is a little bit difficult than the first one, to test our neural network. Moving ahead, we have another screenshot from the training set. Sorry, the training mode of that particular simulator. This particular simulator screen has a record button by which we can record images or videos at 23 fps. Next up, we have the testing mode. So in this autonomous mode, our our model predicts what steering command, throttle, and speed should be given to the car so that it doesn't drift off the road. Now we are looking at the advantages of this particular approach. It is much more efficient than other approaches. In about 98% of the times, we don't need any kind of human intervention in the autonomous driving process. Uh, in fact, in the simulator, we didn't even need to control the car. It drove 100% of the time by itself. Then we can move up to the future scope of this project. We can work on adding more features to this project, like parking assist, or we can enhance the accuracy of this particular project by using other sensors like radars or GPS satellites. So that's all from my side. Thank you and have a great day.